This is Fan of Astronomy, Episode 8.
10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Hello, everybody, and welcome to a very special episode of Fan of Astronomy. I am one of the hosts of this show. My name is Angelo, and I'm joined this week, as with almost every other week, by my trusty hosting partner, Mr. Don Horning.
Thank you, Angelo. And hi, listeners.
Hi, guys. So we actually have a lot to go over in this episode, but it's pretty much going to be about one thing. Obviously, a big news thing hit, but before we get into what actually we're going to talk about, we need to tell you guys about Patreon.
Yes. We do have a Patreon at patreon.com/astronomy, where you are able to, if you really like this podcast, sponsor it with $1 sum every episode. So $1, $2, or even more if you want. And that is sort of a contract between you guys and us. It's just like Kickstarter, but yeah, crowdfunding the podcast. And we need some money to really take this to new heights. So we would very much appreciate that.
Yeah, and I mean, we're not a weekly podcast at the moment, so that does help you guys when you decide what you're going to donate to us. We would really appreciate it. I mean, if you only decide to donate $1, we'll take it. We'll be more than happy with that. And that's only $2 a month for the most part. There are going to be those weird months where, like you get 3 paychecks at work. Same deal. But, so please help us out. We want this show to go on as long as possible, but we do have a termination date, and we're not close to it yet. Calm down. But, we are going to reach a point where we're going to have to decide whether this is financially worth us doing. And you guys, our listeners, are the ones who's going to decide whether it is or not. And you're going to do that by going to patreon.com/astronomy and, giving us your dollars. We don't ask for much. We don't, expect everyone to give it to us. And to be honest, if the decision is between giving us a couple bucks or feeding your children, feed your children.
Yeah, we should be clear that the podcast will always be free, but if you want to sponsor it, you have the option.
Yeah, absolutely. We're not going to go to a subscription or anything, but, we do have to eventually get something out of this.
Yeah, this is pretty much the way I make my living. I do 9 podcasts, and almost every one of them has a Patreon.
So guys, step it up. So we have a big news thing to talk about, though, and we was going to talk about the asteroid belt. Unfortunately, or fortunately, however you look at it, this happened, and this is the TRAPPIST-7. And
TRAPPIST-1.
Well, I'm calling them the TRAPPIST-7 because there's 7 planets around TRAPPIST-1.
Yes.
And this is something that we've never seen before.
No.
Outside of our own solar system, and then even when you consider the subtleties between our solar system and their solar system, it's completely different.
Yeah, we've seen 7 planets in other solar systems, but not like this.
No, actually the only solar system we've ever seen it in is ours, but not like this. So the way we're going to do this is we have the NASA page pulled up, and we are going to read verbatim the article, and we're going to discuss what's going on here between the article and, what's actually happening. And, we're going to put our 2 cents in on what we see going on and what we think's really cool about it. And mind you, we're morons, so listen to the NASA parts more than us, I guess. I don't know. But we're going to speculate.
I need to correct you.
What?
HR 8832 has 7 planets.
Really?
As well. Yes.
See, in this article here, it says... All right, we'll get to it. Anyway.
It's rare.
It's very rare. We'll go there.
HD 100180 also has 7 planets, but 2 of them are still unconfirmed.
Ha! Wait. We've never seen 7 rocky planets around one star.
No, definitely not.
Okay.
Not this close to each other.
No. But I'm going to go ahead and we're going to jump right into this article, and we will discuss as we go, like I said. Article starts, NASA's Spitzer Space Telescope has revealed the first known system of 7 Earth-sized planets around a single star. 3 of these planets are firmly located in the habitable zone, the area around the parent star where the rocky planet is most likely to have liquid water. The discovery sets a new record for greatest number of habitable zone planets found around a single star outside of our own solar system. All of these 7 planets could have liquid water, the key to life as we know it, under the right atmospheric conditions, but the chances are highest with the 3 in the habitable zone. The discovery could be a significant piece in the puzzle of finding habitable environments, places that are conducive to life, says Thomas Zurbuchen, Associate Administrator of the agency's Space Mission Directorate in Washington. Answering the question, are we alone, is a top science priority, in finding so many planets like these for the first time in a habitable zone is a remarkable step forward toward that goal. Forward and toward right after each other. Like that's actually kind of a bit of a tongue twister there. You know, I read fairly well, and that like blah, 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 blah. So, we should start off real quick. Spitzer's Space Telescope. What is that exactly?
Good question.
Oh, geez, Dan. Notes. I write them for a reason.
It's an infrared space telescope.
Yeah, so this is a telescope that we launched in 2003, and it had a planned mission of only 2.5 years.
Yes.
So it's lasted a lot longer than expected, but however, it is a mostly dead scope. The liquid helium that was used for cooling, it's gone. And only the infrared cameras is operational, until the cryogen runs out, which is pretty closely coming. It has an infrared array camera on it, and that is what confirmed all of these.
Yeah, and the reason I was confused by Spitzer is that I wanted to talk about the TRAPPIST telescope, which first discovered this system.
Yeah, which is what the star is named after, but the Spitzer is what confirmed it.
Yeah, TRAPPIST discovered 3 planets in 2015, and this was done by a Belgian team in Chile, because the TRAPPIST telescope is in Chile, and I think the Belgians have been very influential here, because TRAPPIST stands for Transiting Planes and Planetesimals Small Telescope, but it is also a very good Belgian beer. So the telescope is named after Belgian beer. So the Belgian team was probably very involved there.
Okay.
But that was not that interesting, because what Spitzer discovered made this system a lot more interesting.
Yeah, I mean, and that's one of the fine things about science is everything is double blind. If just Spitzer would have located this stuff, no one would say that it was there. But because TRAPPIST located it first and Spitzer was able to confirm it, we know that these are facts.
Yes.
Which is amazing. And what this is it's 7 rocky planets circling 1 star. 3 of them firmly within the habitable zone, which we like to call the Goldilocks zone.
Yes.
And all could have liquid water depending on atmospheric conditions. I can't express enough how much that point must be emphasized.
That is quite interesting. Should we talk a bit about the star itself first?
That's in the next discussion point.
Okay.
So why is the fact that all 7 planets need liquid water?
Yeah, because that's a requirement for life as we know it.
Yeah, so if we have 7 planets that we think could have liquid water, and we're looking for life, 1 and 1 make 3, right? Or wait, no, 1 and 1 make 2. This is kind of a big deal. We don't see things like this every day. I mean, count on your hand how many planets we know of with liquid water in our solar system. 1, we know for sure.
Yeah, we do have some liquid water on moons, but it's only on Mars.
Yeah, and I mean, we have some geysers, which on like Pluto, but that's... I mean, yeah, there's liquid water somewhere on there, but it's not on the surface.
No.
So, interesting.
Because you have to be in this very narrow temperature band between 0 and 100 degrees Celsius to have liquid water. And then you have to have enough atmospheric pressure as well.
Right.
And we don't know that yet.
Yeah, we don't know. I mean, when we're saying atmospheric pressure, it's kind of like you look at Mars, and, we talked about Mars before, and because it has no atmosphere, all of the water just drifted away.
Yes, or froze and are stuck in the polar caps.
Yeah, so, I mean, we need the right atmosphere. We need a lot of things, and they're going to be doing things in the future to prove, I guess would be a strong word. Either way, moving on in the article, about 40 light years, or or 235 trillion miles from Earth. So the system of planets is relatively close to us in the constellation of Aquarius.
Yes.
Because they are located outside of our solar system, these planets are scientifically known as exoplanets. This exoplanet system is called TRAPPIST-1, named for the transiting planets of Planetesimal Small Telescope in Chile. In May 2016, researchers using TRAPPIST announced they had discovered 3 planets in the system, assisted by several ground-based telescopes, including the European Southern Observatory's Very Large Telescope. Yes, it's actually called that. Spitzer confirmed the existence of 2 of these planets and discovered 5 additional ones, increasing the number of known planets in the system to 7. The new results were published Wednesday in the Journal of Nature and announced at a news briefing at NASA's headquarters in Washington. Using Spitzer data, the team precisely measured the sizes of the 7 planets and developed first estimates of the masses of 6 of them, allowing their density to be observed and estimated. Based on their densities, all the TRAPPIST-1 planets are likely to be rocky. Further observations will not only help determine whether they are rich in water, but also possibly reveal whether they could have liquid water on their surfaces. The mass of the 7th and furthest exoplanet has not yet been estimated. Scientists believe it could be an icy snowball-like world, but further observations are needed. The 7 wonders of TRAPPIST-1 are the first Earth-sized planets that have been found orbiting this kind of star, said Michel Guillon, or Michael Guillon, depending on where he's from, lead author of the paper and the principal investigator of the TRAPPIST exoplanet survey by the University of Leiden?
Works for me.
Okay, in Belgium. It is also the best target yet for studying the atmospheres of potential habitable Earth-sized worlds. So, a lot to soak in there.
Yeah.
But the big one is the star itself, which is close, but not close.
Yeah, this is 10 times further away than Proxima Centauri, the closest star. And this means that there are probably thousands of stars that are closer than this one. But it's still pretty close for the Milky Way.
Yeah.
So it's right in our neighborhood.
Yeah, it's weird. Like when they say 40 light years, you go, oh, that's not that far. But when you break it down to miles and you go 235 trillion miles, so that's like 400 trillion kilometers.
Yeah, with our current technology, it's not reasonable to get there.
Yeah, I mean, this is a distance. So, I mean, it's not like we're going to be flying there anytime soon. It's not like we're going to be sending out space probes anytime soon. That would be kind of a waste of time. Like Proxima would probably be the better choice as far as studying goes with actual instruments we can send there.
Absolutely.
But, I mean, this is something that, you know, as space traveling technology goes, would be an excellent candidate for us to actually go to. So, Dan, do you have anything to add after reading over all that stuff? You already talked about the TRAPPIST being a beer.
Yeah, can I talk about the star now?
Yes, this is the star time.
Yeah. So, this star is tiny. It's about half the size of Proxima Centauri, which is a really small red dwarf. We have about 84 Jupiter masses in TRAPPIST-1, and that is below the level for red dwarf. So this kind of star is called an ultra-cool dwarf, spectral class M8. So it's almost a brown dwarf, but not really. So it seems to be on all the time. Brown dwarfs sometimes just shut down, and that's of course really bad for life. But this thing is on all the time, but it's really cool for a star. Its surface temperature is 2,550 kelvins, which is about 1,000 degrees less hot than Proxima Centauri b, and a lot cooler than the Sun. And this means you get this habitable zone really, really close to the star. It's also very young. TRAPPIST-1 is somewhere between 500 million and a billion years old. And if it is 500 million years old, the solar system around it could still be forming. But it apparently it has much less mass than our solar system, so it might be done by this point.
Yeah, I mean, this thing is, sometimes they refer to these M-class stars, these M8-class stars, as substellar objects.
Yeah, for reference, Proxima Centauri is an M6, and that's like, then you are really a red dwarf. You get your red dwarf license.
Yeah, this thing is small. It's barely, I want to say it compares to about 8 Jupiters.
Yeah, its volume is about the same as Jupiter, but it's 84 times the mass.
Yeah, right. So
that's an effect of how stars form. So Jupiter is like the same volume as a star, but far too little mass in it.
Yeah, not enough crap.
Yeah, TRAPPIST-1 has a very high metallicity, higher than the Sun, and it's about 5% as luminous as the Sun. And that's why the planets need to be really close to get enough heat.
Yes, which we are about to talk about. So let's move on in this article real quick. And this is where the meat is. This is where we're going to talk for a while about this. In contrast to our own sun, the TRAPPIST-1 star, classified as an ultra-cool dwarf, as Dan just said, is so cool that liquid water could survive on the planets orbiting it very close to it, closer than is possible on planets in our solar system. All 7 of the TRAPPIST-1 planetary orbits are closer to their host star than Mercury is to our sun. The planets also are very close to each other. If a person was standing on one of the planet's surface, they could gaze up and potentially see geological features or even clouds on neighboring worlds, which would sometimes appear larger than the moon in the Earth's sky. The planets,
wow.
Yeah, the planets may also be tidally locked to their star, which means that the same side of the planet will always be facing their star. Therefore, each side is either perpetually day or night. This could mean that they would have weather patterns totally unlike those on Earth, such as strong winds blowing from the day side to the night side and extreme temperature changes. Spitzer, an infrared telescope that trails Earth as it orbits the sun, was well suited for studying TRAPPIST because the star glows brightest in infrared light, whose wavelengths are longer than the eye can see. In the fall of 2016, Spitzer observed TRAPPIST-1 nearly continuously for 500 hours. Spitzer is uniquely positioned in its orbit to observe enough crossing transits of the planets in front of the host star to reveal the complex architecture of the system. Engineers optimized Spitzer's ability to observe transiting planets during Spitzer's warm mission, which began after the spacecraft's coolant ran out, as planned after the first 5 years of operation. This is the most exciting result I have seen in the 14 years of Spitzer operation, said Sean Carey, manager of NASA's Spitzer Science Center at Caltech IPAC in Pasadena, California. Spitzer will follow up in the fall to further refine our understanding on these planets so that the James Webb Space Telescope can follow up. More observations of the systems are sure to reveal more secrets. Following up on the Spitzer discovery, NASA's Hubble telescope has initiated the screening of 4 of the planets, including the 3 inside the habitable zone. These observations aim at assessing the presence of puffy, hydrogen-dominant atmospheres typical for gaseous worlds like Neptune around these planets. So there's a lot there.
Yeah.
We'll start right there on paragraph 1, where, these things are going to appear larger to the naked eye than our moon does.
It's so weird. Imagine that you're standing on the surface of your planet in TRAPPIST-1 and you see the other planets.
It would be so awkward to watch a storm form on a planet next to you. Like, oh wow, they're getting rain over there. That doesn't make no sense.
It's pretty amazing. B and C, like the first and the second planet, they are about 1.6 the distance between the Earth and the Moon apart. And that's super close.
Yeah, when you're talking, you stick an Earth next to the Earth at that distance, like that's mind-boggling.
Yeah, if you've seen the pictures of the Earth from the Moon, that's kind of the size of these planets on the night sky. Or even on the day sky.
Yeah, it's absolutely unreal. And when we're talking about how close these things are together, which, we were kind of mumbling about this before we even started this, was the gravitational pull. Like you would think, and Dan has a pretty good explanation as to why it doesn't happen, but you would think that you have these planets so close to each other that the gravity must play havoc on each other, but strangely they don't.
Yeah, I think the best example of a system like this in our solar system is actually the 4 Galilean moons of Jupiter. We haven't talked about them yet, but it is believed that Jupiter once had like 30 moons of that size, and it killed almost all of them. But Io, Europa, and Ganymede, they are pretty close to Jupiter, but they survive by resonance rotations around the planet. So there is a resonance system here where the planets have settled down, pulling on each other and sort of finding their orbits. So it seems to be stable.
Yeah, it's like each planet is a Trojan of each other.
Yes.
And that's how they're keeping themselves flowing in the sky.
And I think a very important thing to understand here are that these things, the seventh planet, H, it's the one we know the least about.
Right.
But it's about 0.63 AU from the star. And that's 5 times closer to the star than Mercury is to the sun. So all of these things zip around the star super close. And a year on TRAPPIST B is only 1.5 days.
Ooh, that's fast.
That's, while the sixth planet, G, has 12 days in a year. So it's like 12 Earth days.
Yeah, that's fast. Now, they may be, moving on to the second paragraphs in this article, they may be tidally locked. And we've talked before about what tidally locking is and, true tidal lock, phase locking, all these different types of locks.
Yes.
We could hope that they're phase locked, but that really isn't that different than a true tidal lock. We could hope that they're a 2-3 lock, which would give it some spin.
Once again, if we look at the Jupiter system, they are all tidally locked. And if these 7 planets are not tidally locked yet, they probably will be.
You would think at some point.
The system is still young.
Yeah, you would think at some point that they would, the gravitational pull of the sun would slow them down eventually, but craziness. We could hope that good things are going on there, but we don't really know, unfortunately. Now, with these being so close, as we had said earlier, you would think that if they have water, they should have a very strange result on each other, huh, Dan?
Yeah, they should definitely have tidal effects on each other. So imagine something much bigger than the moon. Looking at B and C, for example, B is 0.85 Earth mass, and C is 1.38 Earth mass. So you have these things much bigger than the moon, almost as close as the moon. So it would create enormous tides on each other but they don't rotate each other. So when C passes B, there's like, whoa, tidal wave.
Yeah, you would think that it would cause some craziness, like here on Earth, we have cities like New York, right there, right on the edge of the ocean. Yeah, you're not doing that here.
It's like, oh, the sea is coming, run for the hills.
Yeah, the tides would destroy these cities. So it would be, if for, say, some reason, and like Dan said, this is a very young system, but if for some reason there was intelligent life there, they would not, by any stretch of the imagination, put their cities right on the oceans, because then we couldn't call them intelligent life.
No, and the sea comes around like every second day. It's like, no.
Yeah, it'd be bad. It would be really bad. And this works the whole way out. It's just so nuts.
Two problems with the star. First, red dwarfs, when they are young, are very flary. They erupts all the time. It has tantrums. And this thing is so small, but I still think it would have eruptions that could vaporize the water on the planet, worst case.
Worst case. Hopefully, though, I mean, they are close, so there is a chance that these things could have very strong magnetospheres, and that would quasi-protect them.
Yes, it would. We also have in our own solar system, when we were 500 million years old, we still had the late heavy bombardment going on, so that was a bad time to live in our solar system. But that might have been caused by Jupiter moving around, and we don't have any gas giants in this system causing havoc.
Yeah, which is helpful. So, I mean, because if there was a gas giant, I don't think that these planets would be as close to the sun as I would think that the furthest one away, what is that, H?
Yes.
I believe H, unless the gas giant was way out there. But if it's too far out there, it's not going to be pulled by the gravitational pull of its parent star. But I would think it would pull H and probably G out towards it a little.
That all depends on where it would be. But,
right.
Being this close to Earth and now us looking so much in the system, I think if there's a gas giant, it has to be pretty far out.
It would have to be like around where Jupiter is here, or even maybe our asteroid belt, but not any closer than that.
Yeah, I imagine that we could detect a gas giant around TRAPPIST-1 at Jupiter distance.
I'm pretty sure we would have found it.
I'm not sure. Now I'm just speculating.
Yeah, I'm pretty sure we would have found it if it was there.
I'm thinking like Planet 9 out.
Oh, wow, that's way out there. I don't know if it could be that far out and still.
I could. These things are often binary, and when they are tied to another star, it can be really far away.
Well, if it's another star, I can see it, but I don't know. With a planet, even a gas giant.
The size object could be quite far out, I think.
Okay. All right. I'll go with it. You know more about this stuff than I do. I will.
Or maybe I'm just making this up, but that's my guess.
Okay.
And then we don't know about asteroids and stuff here, how much junk there is zipping around in the system.
No, we don't know if any of these planets have moons.
Yeah, that's interesting to speculate. Could they retain their moon with these similar sized planets zipping by so close?
I don't know. I mean,
could you even have a situation where they exchange moons?
That would be possible, like a moon doing a figure 8 around a couple of them. I can see them having Trojans before moons.
Yes. Yeah.
Because having all these things so close is going to create a lot of just strange spots where gravity just kind of cancels everything out.
Yeah.
So I can see that, but I don't know about moons because
if any asteroid is supposed to survive around within 0.06 AUs of the star, it has to have some relationship to the planets. Has to be Trojan or a moon, pretty much.
I would think as much. And I mean, if you live here in the United States, and I know that everyone who listens to this doesn't, but you know that one of the big things is people complain about, the amount of money spent on NASA and a bunch of different places. Well, this is how important this discovery was. They put 500 continuous hours. And to do the math, that's 21 days. So that's almost a 15th of the budget that we give, them to operate that machine was put on this one thing.
Wow.
And that's pretty crazy when you think about it because, they usually don't, when NASA likes to do missions, they like to get results quickly because it costs money to do things for extended periods of time. And them doing it for 21 days straight is pretty interesting to me. Like that says that there's a lot of neatness going on here that, the people at NASA, the people 10 times smarter than me says we absolutely have to watch this.
Yeah, I've never seen a NASA announcement that was so excited. I almost thought they were going to announce the discovery of life on an exoplanet.
So did I. I thought that they was going to say was they found the markers.
Yeah.
For, like they're looking, it says in the last paragraph about hydrogen dominated atmospheres. That's what we have.
Yes. They are definitely turning other telescopes on the system now, trying to look for greenhouse gas.
Yeah, I mean, they said that
atmospheres.
Hubble's going to start looking at it, but the reason they want to find hydrogen dominant atmospheres is because, well, we know that that's what helped us have life. Because
and we think that ozone or methane are very likely signs of life. So that's what they're looking for too.
Yeah, I mean, if you have hydrogen, then you could say, well, there could be plants there. And if there's plants there, then what we know from our own history is the plants then oxygenate the atmosphere. Because oxygen was not on Earth at one point. This was all hydrogen around us, and the plants changed enough of it that we can use the oxygen.
Yeah.
Because
we only have this, sorry, go ahead.
I was just going to say, if you have too much oxygen on a planet, there's a bad side effect. Dan, do you know what that bad side effect is?
No.
Fires in the sky.
Sweet.
Quite literally, fires in the sky. Oxygen is a very flammable, gas. And if we didn't use it, and it was still nothing but plants, this is kind of one of the weird things. Like plants came to Earth, and it began to oxygenate the sky. And if an organism didn't come around, like us and, every other animal on the planet that we know of as a walking animal, didn't use the oxygen up, it would reach a point where there was too much oxygen in the sky, and literally the world would burn.
Oh my God.
I
That's why we settle for 20%.
Yes. Yeah, if we got to 30, it'd be terrible.
Oh my God.
As bad as 5 would be for us, because we couldn't breathe, or 10, we couldn't breathe. 30, the world would burn.
Yeah.
You know, like striking a match would be like a federal crime. A strike of lightning would destroy cities.
Yes.
This is, so, I mean, that is the big reason why they're looking for hydrogen-dominated atmospheres. I don't know why they said, you know, like found around gaseous worlds like Neptune. Yeah, that's typical for places like Neptune, but it's also a marker of life.
Yeah.
So, and now we'll move on to the last section of this, and then me and Dan will talk about all the craziness that comes along with this, because I'm sure he wants to talk about colonizing this, because he wants to talk about colonizing everything.
This is pretty far off the colonizing plan right now.
It's a little far off, but there are some benefits to the idea of this. But in May 2016, the Hubble team observed 2 of the innermost planets and found no evidence of such puppy atmospheres. This strengthened the case that the planets closest to the star are rocky in nature. The TRAPPIST-1 system provides one of the best opportunities in the next decade to study the atmospheres around Earth-sized planets, says Nicole Lewis, co-leader of the Hubble study and astronomer at the Space Telescope Science Institute in good old Baltimore, Maryland. NASA's Planet Hunting Kepler Space Telescope also is studying the TRAPPIST-1 system, making measurements of the star's minuscule changes in brightness due to transiting planets. Orbiting as a K2 mission, the spacecraft's observations will allow astronomers to refine the properties of the known planets as well as search for additional planets in the system. The K2 observations conclude in early March and will be made available on the public archive. And there is a link to a public archive, and they are keeping up with it constantly. So go on to NASA's site, find the article. Maybe we can link it in the show notes. I don't know, Dan. And then you can go onto the public archive and you can keep up with this, you know, check back every month or so. Spitzer, Hubble, and Kepler will help astronomers plan for follow-up studies using NASA's upcoming James Webb Space Telescope launching in 2018. With much greater sensitivity, Webb will be able to detect the chemical fingerprints of water, methane, oxygen, ozone, and other components in the planet's atmosphere. Webb will also analyze planets' temperatures and surface pressures, key factor in assessing their habitability. NASA's Jet Propulsion Laboratory in Pasadena, California, manages the Spitzer Space Telescope mission for NASA's Science Mission Directorate. Science operations are concluded at the Spitzer Science Center at Caltech in Pasadena, California. Spacecraft operations are based at Lockheed Martin Space Systems Company, Littleton, Colorado. Data are archived at the Infrared Science Archive housed in Caltech IPAC. Caltech manages JPL for NASA. For more information about Spitzer, blah, 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 blah. Okay, so
all right.
There's a lot of links here. We'll try to stick all these into the show notes when we go about it, because, you know, it's like the Spitzer link, the TRAPPIST link, information on exoplanets and what have you. So they find...
of course, we will also update this story when new data comes out.
Oh, absolutely.
As we do with Proxima Centauri.
Absolutely. So, at least the American science community and NASA, and I'm sure, you know, the other countries will jump into this as quickly as they are, you know, able. They're throwing everything at it.
Yeah.
4 telescopes, 4 crazy telescopes, doing
more
nothing.
Data will come out very soon.
Yeah, doing nothing but staring at them. Like, that's absurd.
Yeah.
And it's kind of like what you said, like you were shocked at how enthusiastic they was to release this information. I don't remember, and now mind you, I wasn't alive during the moon landing, but I don't remember them throwing a news conference out like this.
Oh, they have, but I don't remember they doing it this way with so much pre-announcement and like, whoa, this is super big.
Yeah. I mean, like, you know, they do news conferences, but not like this. No. Like, this was almost like, you know, a president coming out and saying, we're going to invade, you know, Canada. You know, like, this was a big deal. Every news station was tuned into it because, like, they sold it before we ever got any idea what they was going to announce.
Yeah.
So, Dan, I know you want to talk about colonizing.
Yeah, I think it's very early to talk about colonizing this because we know so little, but one important fact I want to mention is that with our current rocket technology, it would take about 2-3 days to jump between these planets. And if they have atmospheres that are good for braking spacecraft, then it would be really easy for us, if we were in TRAPPIST-1 today, to travel between these worlds. This is not as complicated as going to Mars. And we have the technology to go to Mars. We just don't do it because it's expensive. But between these worlds, you could just hop around, which is kind of exciting to think about. I'm pretty negative about the probability of life here. We have the tidal locking. We have the erupting star.
I'm not.
The system is so young, but we only have the one single example of life in the universe from the Earth. So we don't really know how long it really takes to form life and what the variables are for life creation. So it's not impossible.
Yeah, I mean, I know we chatted a little bit before the show about, you're pretty down on, is there a chance that there's life there? I personally believe that life is a lot more common than we give it credit for. Just because we haven't found it doesn't mean it doesn't exist. Like, we think that there might be life on Mars.
Yeah, if we find life on Europa, for example, the moon of Jupiter, which is still, I think, the most likely place in the solar system.
Yeah.
Then all bets are off. Then, like, whoa, 2 examples.
You're right.
So then life could be super common.
I mean, I think that life, I mean, especially because when you look at some of these, like space rocks that, they take out there and, bring back, and the flu survives. Yes. You know what I mean? Like, it survives the trip in outer space and back. And I just feel like life is a lot more rugged than we give it credit for. So I think that there could be life on these planets. I don't expect them to be intelligent life.
No, that would be very quick.
Yeah, that would be astonishing, and we would have to change all understanding of how rare intelligent life is. No question. But I think
unless they have been colonized.
Possible. Bacterial life I do expect to find as native. And maybe even plants.
I have to add something about life. We still don't really know how life is created. We have managed to reconstruct we have managed to create in the 50s the essential amino acids for life.
Yep.
But the spark itself, the ability to make them live, still eludes us. So like step 2, we can't figure out.
Let me fill you in real quick, Dan.
Yeah.
Okay, you get a man, you get a woman. They go into their bedroom and they do the naughty thing. And then 9 months later, and then 9 months later, life comes out.
But I have to practice this.
This is how you make life.
Okay. And then after you've done that, you go to TRAPPIST-1 and voila, you have life there.
Yeah, it's kind of the weird thing. Like, I mean, it will be hard to decipher whether there is life. But if we were to colonize this, and I know this thing is so far away that for us to do that, we would need new propulsion technology, or we would need to learn to fold space, which that's something we're going to get into way down the road.
Yeah. If you also think about like the future on a age of the universe scale, the smaller star is the longer it lives, and this thing will live forever. So it will live at least 1,000 times the age of the universe.
So that's a bonus?
Yeah, so that life will appear in TRAPPIST-1 at some point is much more likely than it's there now.
Yeah, and if we were to colonize it, that would be a bonus. We wouldn't have to worry about this star blowing up on us.
No, once it settles down, like Proxima Centauri B is about 10 times, it's about 5 billion years old, and it's still not settled down, but once the star settles down, it's a pretty nice place.
Yeah, I mean, so there is bonuses there. One of the bonuses that you talked about earlier was that we could jump from one to another if the need be. So mining and things like that, imagine, that'd be so cool to do that on a cosmic scale. Cause like, there would be the one planet that would be like the planet. And the rest of them, they would all be mining colonies. It would be like a bad episode of Gundam Wing.
Yeah.
So, I mean, that's cool. If you're running out of materials on one planet, you just go to the next one and get them there.
Yeah. The gravity on the planets are pretty varying a lot, but they're all bigger than Mars, and 2 of them are bigger than the Earth.
Yeah, so they wouldn't be overly different than what we are used to.
Yeah, and I don't think, we know the radius of them.
Oh yeah, they know the size of them all.
Yeah.
Except for the
With
last
the
one.
radius and the mass, we can calculate the gravity, but I don't have that in front of me.
Aw, Dan.
Yeah, but it's Earth-like. It's all better than Mars.
Yeah. And, I mean, watching the sunset there would be really cool.
Yeah, watching those planets zip by would be really cool.
Yeah, that's more what I was thinking, when you just, oh, it's 2:00, zip, and it's gone.
And there's the tidal wave. Ah.
Yeah, now everyone grab your umbrellas. So, I mean, it would be, I'm excited for this discovery. I think that there's a lot of possibilities here. I mean, there's a lot that we can shoot down pretty quickly, like in the next couple years, but until that time when all that data comes back, there's a lot of cool speculation we can do, it would be wonderful to be in NASA watching this data come in.
And this once again reminds me, we are truly in the golden age of astronomy. Like 25 years ago, we didn't even know if there were exoplanets. But now these things happen. We got Proxima Centauri B recently, and then this one. And it's like more exciting news to come.
Yeah, and we should take a minute to talk about this James Webb Space Telescope that is launching next year.
All right.
This thing is the most powerful telescope that we have ever sent into space. I don't want to say that we will ever. And this thing can detect at distances that are unbelievable the smallest things. So when they say chemical fingerprints of water, like they're going to be able to look at a planet 40 light years away and detect water. I mean, yeah, it's really cool when you hear them say that and you go, yeah, that's NASA. But I mean, think about if they tasked you, the listener, personally, to go out there and figure out a way to come up with. I mean, we're just piggybacking off of the information. We don't know how to do any of this crap.
I want to mention one more exciting thing about this system. With the star so close to these Earth-like planets, this could probably be an excellent opportunity to detect the first exomoons, because we still haven't detected an exomoon. That's a moon around an exoplanet in another solar system. But we have 4 ways that could be applied to TRAPPIST-1 over time that could maybe work. So we could use Kepler. We could detect tugs from exomoons on these planets when we get to know them better and have more data. We could also see an exomoon transit TRAPPIST-1. And because TRAPPIST-1 is so small, this could be detectable. There could be a dip in the observed light of TRAPPIST-1 from a big exomoon of one of these planets.
Yeah.
And we could also get gravitational microlensing for these exomoons. So this is an excellent place to detect an exomoon.
I would think that it would be a lot like observing Venus in our sky today, where you would look at one point and you go, all right, there was a dot there.
Yeah.
Okay, there's a dot on the other side X hours later. Like, there's something shooting around that. But it would be an excellent opportunity if these things have moons. We don't know that they do.
Oh.
So I'm hoping that James Webb. Why do I keep calling it James Wood? I must have knew a James Wood at some point in my life. I don't know, but I actually wrote that in the notes a couple times and had to go back and switch it because I'm like, it's James Webb. Why do I keep calling it? But at any rate, we need to be sure that there are a moon first. I'm hoping that the James Webb telescope will be able to detect that quicker than these other ones. I can't wait till that thing launches.
Oh, that will be great.
Yeah. If you go on the NASA website, the original page for this, there is a VR surface of planet TRAPPIST-D in a 360 view. So you're able to, really look around and get a good glimpse of it. There's tons of information on it, more than we've gone over in this show. But, we're not the actual astrophysicists. So we're just reading what we see and we're contemplating the possibilities.
Yeah.
Absolutely cool. Do you have anything else about this subject that we need to talk about before I bring up the fact that I'm a fuck up?
Yes, one more thing about exomoons. The most exciting exomoons, just like in our own solar systems, are probably the ones orbiting gas giants, but and that's not a thing here. And they are much harder to detect. So then I think I'm done with TRAPPIST-1 for the time being.
Yeah, for the time being, we will absolutely come back to this, because I'm as excited at this as Dan is about Centauri.
Yes. Oh, it's so close.
I mean,
Yeah, one more thing then. As with Proxima Centauri, if there is vegetation on these planets, it's all black.
If the tidal locking ideas hold. Or wait, no, you're right, because the color of the moon, or the color of the...
Weak star, you need to get as much heat as possible.
Yeah.
So the black forests are there too.
Oh boy, Hobbit ninjas.
Yes.
They found their way back into the show.
Amazing.
Yep. Okay, so I'm an idiot. I'm willing to accept all emails saying that I am. When we talked about the moons a few weeks ago, I misunderstood something about it, and I passed bad information on to you guys, and I feel terrible about that. And anytime we screw up, we're going to tell you that we screwed up as soon as we find out that we did screw up. Luckily, I didn't find out from one of our listeners. I found out just from my studies. All the craters on the moon are round, regardless of the impact direction that came in. I recently said that depending, some of them came in at an angle and they created ranges. They do have ranges on the moon, but these happen because of multiple impacts close to each other. So if you have 4 impacts fairly close to each other going in one direction, like straight up, you're going to get what looks like a ridge range on the one side. Now, the reason this happens is because these things have kinetic energy explosions the second they hit. It's like throwing a snowball against a wall. Okay? It doesn't matter what angle you throw that snowball against the wall. If you throw it hard enough, it blows up and sticks the same way. So I'm an idiot. A little bit of physics would have told me that I was, and I didn't look into it closely enough, and I went off of my own kind of understanding of things and forgot about kinetic explosions. So I'm sorry about that. Dan gets a chance to harass me now. Go for it.
No, I'll try to, in the grandeur of my heart, find the ability to forgive you. So I'll work on that.
I mean, it's an easy leap to make, but I still feel bad for putting out bad information. Again, anytime we screw up, we will let you know.
Yes, and if you hear us screwing up, please correct us.
Yeah, we don't want to put out bad information for anybody. Please let us know if we screw up. I am embarrassed that I screwed up this time, so I'm sorry. I will try like hell not to let it happen again, but I promise you it will.
Probably.
Yeah, I mean, there's just too much out there. I don't know everything about space, but I do study it enough that I should have known better. I really should have. Damn, I feel so bad. So after I pour my heart out there and absolutely sound like a scared child, oh, the tweets, I hope they come. We're going to take a real quick break here, and then we're going to be back where I have some words for some people.
Yes, you do.
And they're not going to be kind. So go ahead and listen to this Facebook plug, and we'll be back in a moment.
Hello. Are you enjoying the show so far? I hope you are. Well, if so, I encourage you all to pause the show. Don't worry, we'll wait. Go to facebook.com/fan of astronomy and hit that like button. You'll be one of the first people to know when a new episode comes out. Also, on that page, the guys post articles on the latest news in the astronomy field and outer space in general. You also get to interact with the hosts of our show, Dan and Angelo, there, so please hit that like button on Facebook. Thanks.
Okay, so here's the deal. In the past, when I've done other podcasts, I've had these moments, and I don't do a lot of these, even though I could probably do one every show on everything that I ever do. They lose their punch when you do them too often. But once in a while, people piss me off. And when they piss me off, I feel the need to let them know that they pissed me. And I kind of go on these rants. Again, I didn't even know if I was going to bring them to this show. I didn't see how it was relevant. How could we possibly bring my rants to a show about astronomy? And then this week happened, or this past week, however you want to look at it. A man, Kyrie Irving, he is the point guard for the world champion, NBA champion, however you want to look at it, Cleveland Cavaliers, came out and said that the earth was flat. Okay, earth's flat. All right. And then Draymond Green, from another basketball player, I believe he plays for the Golden State Warriors, he said the same thing, basically. He didn't flat out say it. He kind of said that, Draymond might be, or not Draymond. Draymond's the one who said this. Kyrie might be onto something. And that bothered me a lot more than it should, but it does. And then, for you wrestling fans, AJ Styles, world famous wrestler, he came out and said kind of the same thing. Now, I am a very forgiving human being. I believe that everybody has an opinion. Everyone is entitled to their opinion. I don't care what said opinion is, but you don't have the right to have your own goddamn facts. You cannot in any way hand me beeswax and say that it came from a grizzly bear's ass. That doesn't happen. Okay? So when these people propagate something like the flat earth, I don't know what you want to call it, conspiracy, because that's what these people seem to fucking think, is that NASA and the U.S. government, completely excluding the fact that there's thousands upon thousands, if not millions, of amateur astronomers who don't have anybody who they have to answer to, all say that the world is flat. And here's the thing. You don't need to go into outer space and look back to see that the Earth is round. All you have to do is get on a boat. You don't even need to fucking fly. You need to be on a boat. You go in one direction. After you've gone in said direction for so long, you end up exactly back where you started. Why? Because the world's fucking round, okay? Now, you would think that, it's just some basketball player, blah, 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 blah. Well, first off, Kyrie Irving he went to Duke University. This is one of the educational hubs of the United States. This man should be smarter than this. Plain and simple. No ifs, ands, or fucking buts about it. And why should I care that, these three random people believe that the Earth is flat? It's because they are people of impact. Children look up to these people, okay? And by them propagating this bogus idea that the Earth is fucking flat, what they're doing is making the next generation of kids stupid. You have the right to be stupid if you want to be stupid, but don't make the next people stupid. If you have something stupid to say, keep your mouth shut. Especially if you're in a position where you can influence others. That's wrong. That's damaging to society, because while you're not in a position to have any real power and possibly create legislation that, that says the way the country or the world is going to go forward, the next generation kids, one of them might. And that's fucking dangerous. And that's where the problem is. It's bad enough that we've let science slip in many societies across the country, including the United States, to the point where people can actually fucking believe the world is flat. But when you have people who have enough status and kids look up to them to continue to go on and propagate this idea, it's just wrong. Now, I know Kyrie Irving's not listening into this, and the truth is, why would he? He has better things to do with his time. Although, you can send it to him if, by chance you happen to know him. Because the Earth is round. There's no ifs, ands, or buts about this. You cannot say that, again, back to the grizzly bear thing. I mean, there are certain things you can't argue. Look, if you want to argue politics, I can argue politics with you all day. Okay? Because politics is just a way of, you form into a political party based on the way that you want to see, you want to live. And then you push the way you want to live onto other people. That's what politics is, whether you really want to hear that or not. Science is different. Science is based in fact. There's no opinions there. You can have, opinions on things when they have not become flat fact. You can't tell me that, oh my God, there's just so many things like, milk comes from a cow. Milk comes from a mammal. That's where milk comes from. You can't hand me shark shit and say that it's milk. Just plain and simple. When you see these flat earth people, I chastise the shit out of them when they show up on my Facebook page, and I would hope that you people would ridicule them just the same. Now, that does not mean that you shut them up or, everything else, but you make them understand how stupid they sound. There is no wall of ice at the end of the world holding everything together. Just think about how fucking stupid that sounds. I mean, really. There's a wall of ice out there. That makes no goddamn sense. If the Earth's flat, that can't happen. Some of these people still believe that the Earth is the center of the universe. And these flat earthers believe that, because without that, it doesn't work. The math doesn't work. And some of the reasons, if you go up in a plane high enough, yes, if you're in just a local commuter plane, you're not going to see the curvature of the Earth. I'm sorry. The Earth's really fucking big. But if for some reason you were in a plane that, goes across seas and what have you, if you look out the window, you can see the curvature of the Earth. I've seen it. I've seen it. It's there. And some of these people, they use this example of this one guy who, some rap guy, I don't remember his name, who was standing on top of a mountain and he could see Manhattan. And he shouldn't have been able to. Well, he forgot to mention that he could see buildings taller than like 15 stories or 16 stories or something like that in Manhattan. He couldn't see the actual island. Why? Because the Earth's fucking round. Oh, please, this bothers me more than it should, but round Earth, come on. The Earth's round. You don't have to don't lie to yourself that the Earth's flat. And if you have a friend that believes the Earth is flat, it is up to you. As somebody of common sense, I hope you have common sense if you're listening, to prove to them that it is in fact round. And I don't care what way you come up with to prove it to them, but we have to, because these people are becoming people of influence, and that's a problem. You have the right to be stupid. You don't have the right to pass your stupid on. So, Dan, that was a little shorter than I thought it was going to be.
Yeah, I have no objections. If you believe the Earth is flat, you don't like facts. But I did look up the origin of this, and it's from a theory called the synthetic method, which places emphasis on your sensory observations over irritating things such as math or facts.
Math, physics, the things that make things work. Gotcha.
So here is the flat Earth theory in short. So the Earth is a disk. The Arctic is in the center.
Uh-huh.
Antarctica is a 150-foot tall wall of ice, only half the size of the wall in Game of Thrones. And it's guarded by NASA employees, so to prevent people from climbing over and falling off the disk. You get day and night by having a sun and a moon that are actually spheres, and they are the same size as you can clearly see. They are 51 kilometers across, and they move in circles about 4,800 kilometers above the plane of the Earth. When you have the stars about a little higher, and then you get these nice illumination of the Earth. But this can't explain solar eclipses, so you have to add an anti-moon that you can't see, that just moves in front of the moon sometime. Of course, you don't have gravity. Gravity is an illusion. Stuff accelerates downwards because the disk of the Earth is actually accelerating upwards at 9.8 meters per second squared. And that is because of dark energy. Whoa! And that means that the Earth will eventually reach the speed of light, which is a bad thing.
Yeah, and I've also seen that our planet is being accelerated upwards because it's on the back of a turtle.
Standing on a turtle, right?
It's on the shell of a turtle. A giant cosmic fucking turtle. Now, they're taking a lot of science words there, and they're putting them together and using them however in the fuck they want. But the fact that they have to come up with anti-moons, you can't see these moons, but they exist. And that's what holds their fucking theory together? I'm sorry, but that's too far of a goddamn leap rather than just take the facts we have and go, yeah, all that shit makes sense. I didn't have to add nothing crazy to it.
Yeah, I would be really surprised if any listener of this show believes that the Earth is flat, because kind of astronomy becomes very uninteresting if you believe the Earth is flat.
Well, this is the thing. It doesn't matter. I don't think the listeners of our show actually believe that the Earth is flat. I don't. My thing is, I'm sure that they know people who think that. And the only reason I say this is because these people show up in my Facebook feed.
Wow.
They show up on my Twitter. So if the people I interact with, I come across these goddamn people, then I'm sure other people come across. And, this is my problem with the whole alternative facts thing. There are no alternative facts. There's facts and there's bullshit.
Yes.
And this is bullshit.
Oh, yes.
One of the things that I think trips people up, and it's people who don't understand science enough, is that when we come to what we refer to as fact, it's called theory.
Yeah, I was just about to say that. That's like the Big Bang theory and the theory of relativity. It's not hypothetical. It's proven theories.
No, when we call it a theory, it's not. People think that a theory is something that we're still working out. No. That's a hypothesis.
Exactly.
When you're sitting there, with your buddies and you're trying to come up with, how to beat some monster in some D&D game or something, you go, I have a theory. You're using that word wrong.
Yes.
Okay? You have a hypothesis. An idea is not a theory. A theory is a fact. And it's as close to the reason we don't call them hard facts is because nothing in science they consider truly hard facts. And that gives people wiggle room to come up with crazy shit like this.
Yeah.
Where if you just said, yeah, this is a hard fact. I mean, nobody argues, if you pick up the Crayola crayon that says blue on it, you don't argue that that's actually green. But technically the theory is it's blue.
Yes. I think a good example of this is the theory of gravity as explained by Newton. In itself, it's correct, but on certain scales, it breaks down and needs the theory of relativity to work.
Yeah, and it also needs, dark matter and dark energy to make it work completely on the grandest of scales. So, yes. We have facts. And, I think the Earth being round, you don't even have to get into things like the theory of relativity or the theory of gravity. Like, you don't have to get into that complicated of a thing. The Earth's round. We have pictures of it. And those pictures aren't, and this is one of the things, okay? They say that all the pictures, okay, are, one of the problems they have with it is they're all multiple pixeled pictures. And they can make anything round with multiple pictured. They can do that on their phone, which, by the way, they use off of a satellite that is fucking going around the Earth. Calm down, Ange.
I'm looking out over the Baltic Sea right now, and I can't see Russia, so...
Yeah, right? Like, I can't see California.
Yeah.
You would think, okay, let's put it this way. I cannot see the largest building, I believe, in the United States right now is Sears Towers in Chicago. I believe, I'm not 100% sure. I haven't checked up on my architecture recently. But you would think from Pittsburgh, there's really nothing blocking the view of the Sears Towers between Pittsburgh and Chicago.
No.
There's no mountain ranges. It actually gets flatter. And I have a bunch of Great Lakes I can look over. So why don't I see the top of the Sears Tower if the Earth is fucking flat? I mean, it breaks down on so many levels. I can't understand why people in the year 2017 still believe this crap.
If you are really interested in flat Earth theory, there are some interesting experiments that you can read on. And then as an exercise, you can try to figure out what's wrong with them.
I can tell you what's wrong with them from the jump. They say that the Earth is flat. That's where their whole argument breaks down. Like, you have to do multiple pixeled pictures of the Earth. Why? Because it's a big goddamn place. It's hard to get one picture perfectly of the Earth. We have one that we took. And it was during one of the Apollo missions on their way back from, the moon. They actually stayed on it long enough that the moon had shifted to the dark side, where the dark side was facing the sun, which is a bad thing because when you get up there and you're actually walking around on the moon, you need to be in the sunshine. But they stayed up there long enough that as they was coming back, the moon was on the dark side and they actually could see the full Earth. And they took a picture. There's one in existence. We don't send people up there all the time, and we especially don't send them up there to take pictures of the Earth.
No.
That seems like a huge waste when there's things like TRAPPIST-7 out there, or TRAPPIST-1 out there with its 7 goddamn planets.
Yes.
I mean, could you imagine them, for 500 consecutive hours, we're going to take pictures of the Earth.
That would be kind of boring.
That'd be a gigantic waste of goddamn money.
Yeah.
Gigantic waste of money. So, if you know a flat earther, please, when they pop up on their Facebook, shoot down their way, please. Please. This is pissing me off beyond all belief. And what drives me nuts more than anything is this group of people are growing.
That's amazing.
Yeah, they're not going down in numbers. They're growing. Because at one point, their numbers was 0. The world accepted it. And now they don't so much. So, whatever. Dan, you want to plug iTunes, Google Play, and Facebook and stuff for me? I got to calm down.
We do want iTunes reviews. Because iTunes reviews and reviews on other platforms, if you listen on Android or Google Play, will help increase the visibility of this podcast and get us more listeners and hopefully more sponsors. I post every episode of Fan of Astronomy on YouTube as well, so if you have any problems accessing the MP3s, the shows are on YouTube as well. We are also on Facebook at Fan of Astronomy. Just search Fan of Astronomy in Facebook and you will find us and can talk to us there.
Yep.
I look at messages there maybe 20 times a day, so we would respond pretty quickly.
Yeah, we also post at least twice every day. So
Yes.
we do try to keep you up on the latest in science information. I know I posted something today about the naming conventions for the Plutonian system.
Yes, I tend to, now I'm deep into the main belt, the asteroid belt. So I find interesting asteroids all the time. I also can't keep my hands away from Planet 9 and Proxima Centauri.
Yeah.
Anything comes up there.
I know I posted that one thing for you.
Yes. Yeah.
I was like, this is
You
just
can now
ridiculous.
help. Yeah, you can help search for Planet 9 as an amateur astronomer.
Yeah, it's very cool. Please go to YouTube, comment, hit that subscribe button. Same thing on iTunes, Google Play, and please check out the Facebook. That's very important. If you wanted to get a hold of us, you could go to aofcast@gmail.com, and you can send me an email, and you can tell me how big of an idiot I am because I didn't think about kinetic explosions. I want at least one of this, at least one saying that I'm a moron.
Okay, I'll send you one.
Okay.
If nobody else does.
Yeah, it'll be good. You can also find me at FOA Angelo on Twitter and at Gongsuo on Twitter as well. Recently, I have been shying away from Twitter because, as an American citizen, it is a cesspool. With the recent elections, it's just between both sides arguing with each other. The place, it's just a cesspool. I kind of stay away from it, but I do retweet some cool science things that I find, and I occasionally complain about random myself. Dan, if people wanted to find you, where would they find you?
I'm on Twitter as Dan Horning, where I post stuff about all my YouTube and podcast projects. The closest podcast to this one, orbiting very close to it, is Fan of History. Check that out when I cover ancient history with Brennan Rankin in English. Yeah, that's about it.
Okay, that's it, really? Okay.
Well, one more thing. Yeah, regarding your president, Mr. Trump. He has now, just read this, that he has ordered NASA to look into putting 2 people on the next rocket launch for the moon. So he wants to get back to the moon, and that's interesting.
That's cool. I appreciate that. Any money that goes
like a year in advance, it probably will not work.
Any money that goes into the NASA, I'm happy about.
Yeah.
By the time they actually get everything together and say, okay, we have the people, he might not be in office, and they can take said funds and reallocate them to more important things. But I'm cool with that. Well, when you first brought him up, I thought you was going to talk about something else, and I would have to edit it all out because you're Swedish and, all that stuff.
Yes.
But that's how you can get a hold of us. Next episode, we should be starting the 2-part series on the main belt.
Oh, yes.
After comprising all the data that I did on the main belt for the past 2 weeks, it became quickly apparent to me that it needs 2 shows.
Yes.
The information that we have on the Big 5 that is in that solar system, that'll be its own show. Or not solar system, in the asteroid belt. It will be its own show. And then in the other show, we're going to just talk about the belt in a more general term. How it was formed and everything else like that. So we're going to have a whole 2-part series on the asteroid belt, and we will talk about even the crazy stuff that Hollywood has gotten wrong about the asteroid belt, because I have to have my craziness just as Dan has to colonize everything. So until we talk about that again, I thank you all for listening, and remember, science is very interesting, and especially when you're talking about outer space, keep looking towards it. It'll always surprise you. Have a good one.
What'd you think? Did you enjoy it? Well, if you did, head on over to patreon.com/astronomy and pledge to these guys. For each patron they receive, the more they will be incentivized to improve the show. So help them out so they can help you out and throw them a couple bucks an episode. They will really appreciate it. Thanks.